In this lesson, we are going to examine how to create a base flange. A base flange is the first feature in a new sheet metal part. And when you add a base flange to a SolidWorks part, the part is then designated as a sheet metal part. To access the base flange command, we can go to the pull-down menu Insert, Sheet Metal, Base Flange, or we can simply right-mouse click on an existing tab and select Sheet Metal. Going into the Sheet Metal Command Manager, notice we have many commands specific to sheet metal design. However, at this time, only 2 commands are available to us. And in this lesson, we're covering base flange, so I'm going to go ahead and select it. The very first thing I am prompted for is to select a plane on which to create a sketch. This is similar to the extrude command, where you create a sketch first, then you complete the extrude. So I'm going to go ahead and select the right plane, go to my line tool, and draw a simple U shape. I'll then apply a couple smart dimensions. We'll make this leg 25, along with this leg, and the bottom we'll set to 75. I'm going to add a relation between the midpoint and the origin of coincidence. Now, before I close out of the sketch, I do want to mention that I did not place any radiuses in the sketch, nor did I apply any thickness to the sketch. That will be taken care of inside of the Property Manager for base flange. So let's go ahead and close out of the sketch. Property Manager appears. Very first thing in the Property Manager is extrude distance. I'm going to change this to midplane and apply a distance of 100 millimeters. And notice the preview on the screen update. The next item in the Property Manager is sheet metal thickness. Right now it's set to 1.5. Let's change this to 2.5. And below sheet metal thickness, I have a reverse direction. This will apply the sheet metal thickness of 2.5 to the inside or outside of the sketch. Keep an eye on this area here. Right now the 2.5 is applied to the outside of the sketch. I'm going to go ahead and check that box. And now notice the 2.5 is applied to the inside of the sketch. I'll uncheck it, and now it's back to the outside. I'll leave it to the outside. The next item in the Property Manager is bend radius. Let's change this to a bend radius of 3. And what's important to know here is the bend radius is always the inside radius. Moving on down the Property Manager, I have bend allowance. The bend allowance is nothing more than a measurement of how much extra material is required to accommodate a bend in a sheet metal part. Now I do have some choices here under this drop-down box of bend table, K-factor, bend allowance, bend deduction, and bend calculation. We're going to cover these in more detail in a later lesson. So I'm going to leave it at the default value of K-factor of 0.5. I also have an option for auto relief. Even though auto relief is not needed in the part I have on the screen currently, sometimes when you put a bend in a part, you need a relief cut in order for that bend to take place. And that's what this portion of the Property Manager is used for. And some of our options is a relief cut of rectangular, tear, and obround. And we'll cover these in a later lesson as we apply more features to the part that we have on the screen. Now before I close out of the Property Manager, notice I do have a drop down here for sheet metal gauges. And if I select it, I now have an option for Use Gauge Table. So I'm going to go ahead and put a check mark there, click in the drop down. SolidWorks provides a handful of default sample tables. So for example, if I select Sample Table Aluminum, in the Property Manager, instead of specifying a thickness, a bend radius, a K-factor, that's taken care of by this table. All I need to do at this point is to select a gauge thickness. So if I select a gauge thickness of 14, notice the thickness, bend radius, bend allowance, those values are inputted based on that table. But you always have the option of overriding those values. I'm going to go back and uncheck the gauge table and use the settings I applied earlier. So this should be 2.5. And we want an inside radius of 3. And like I mentioned before, we're going to leave the K factor at 0.5. I'm going to close out of the base flange command. And we have a simple sheet metal part on the screen. Now let's take a look at the feature manager tree. By creating that base flange, we have a couple new features in the tree. We have a cut list, which we'll talk about later. We have our base flange command, but we also have a feature called sheet metal. And then we have one that's currently suppressed called flat pattern. Now if I edit the base flange that we were just in, notice I don't have all of the values or inputs I had originally. All I have is the extrude, and notice my sheet metal thickness and my inside bend radius is grayed out. So what happened to those other values? Well, let's go ahead and close out of the base flange command and edit the sheet metal feature. Because those values for bend radius, sheet metal thickness, and bend allowance pertain to the entire sheet metal part, SolidWorks places them under the sheet metal feature. So this is where you can make the changes for those items. I'm going to go ahead and close out of the sheet metal feature. And the last one here is flat pattern. If I expand the flat pattern, notice I can right mouse click and I can unsuppress, which basically unfolds the sheet metal part on the screen. Now notice we have these center lines represented here on the unfolded part. These are referred to as bend lines. These are great for dimensioning too if you need to provide a drawing in a flattened state. Now to place this part back in its bent state, we simply go back and suppress. Because we need to do this on a regular basis, we actually have an icon for this. Flatten. And notice when you select it and unselect it, the part flattens and unflattens. And this completes our lesson for base flange. Now we're going to take a look at bend tables for sheet metal parts. Bend tables allow you to specify the bend allowance or bend deduction values for a sheet metal part. The bend table also contains values for bend radius, bend angle, and part thickness. Now there are two types of bend tables you can use: text files and Microsoft Excel spreadsheets. SolidWorks recommends you use the Microsoft Excel spreadsheet unless you have legacy bend tables from SolidWorks 2000 or earlier. Plus, it's important to note that if you create a bend table as a text file, you will need to provide that bend table text file when you share the sheet metal part file. Whereas, if you create an Excel spreadsheet, it is embedded into the SolidWorks sheet metal part file. While you can create a new bend table by going to Insert, Sheet Metal, Bend Table, New, it is recommended that you rename and edit an existing bend table provided by SolidWorks. To find these existing bend tables, we need to go to the C drive, Program Files, SolidWorks 2014. Now yours may say SolidWorks Corporation, CORP. SolidWorks, Language, English, and Sheet Metal Bend Tables. Inside of the Sheet Metal Bend Tables folder, we have two subfolders: Bend Allowance, Bend Deduction, and 5 sample tables. This last one here is a text file. Even though it's a BTL extension, which is renamed by SolidWorks, this is still a text file. So to open it, I am going to double click on this sample text file. And notice this is nothing more than a regular text file that you can go through and edit and change the values as needed. I am going to go ahead and close out of the file. And before we move on, it's important to note that anytime you modify one of these files, and these are all sample files, that you should make a copy of it before you modify it. That way, you keep the original sample files intact. Now let's take a look at one of the 4 sample Microsoft Excel spreadsheets. We'll open Metric Base Bend Table. Now notice, after opening the file, you'll see the values are not filled in. This is for you to complete. If you want to see a completed table, we'll go ahead and close out of this. go into the bend allowance folder, and notice we have 4 more sample tables, which these are completed. So I'm going to go ahead and open up table 1, bend allowance, and there you go. And in this table here, you can see the values are taken from the Machiner's Handbook, 26th edition. Now that you understand the difference between text files and Microsoft Excel spreadsheets, where to find the files, and how to modify them, let's take a look at how to apply a bend table in our sheet metal part. I'm going to go ahead and close out of this Excel file, close out of this dialog box, and I'm going to go over to my feature manager tree, expand this sheet metal feature, right mouse click on sheet metal 1, and edit feature. You'll notice the bend allowance is grayed out. Now why is that? Well, I'm going to go ahead and close out of sheet metal 1 feature. And if you recall, I expanded the sheet metal feature and edited the sheet metal 1 feature. You want to make sure if you have a multi-body sheet metal part that you do expand this if you do want to make changes to a specific body. That's not the case here because we do not have a multi-body part. So I'm simply going to go up to sheet metal, edit feature, and there you have our bend allowance, which is not grayed out. I'm going to click the drop-down list and select bend table. I'll then select browse, and let's scroll down, expand the sheet metal bend table, select bend allowance, and OK. And then I'm going to come back to the drop-down list here and select table 1, bend allowance. And all I need to do is simply close out of here. And that bend table that we just selected is now applied to the sheet metal part. Let's go back and edit the sheet metal feature and look at other type of bend allowances. The next one is K-factor. K-factor is a ratio that represents the location of the neutral sheet with respect to the thickness of the sheet metal part. When you select K-factor as the bend allowance, you can specify a K-factor bend table. SolidWorks also comes with a K-factor bend table in a Microsoft Excel format in the same directory we were just in. And you can see a K-factor bend table as a Microsoft Excel spreadsheet. The next 2 bend allowance options are bend allowance and bend deduction. Both of these allow you to input your own values to determine the flat length of sheet metal part to give you the desired dimensions of the bent part. These 2 options are generally used by individuals experienced in sheet metal design. The last option is bend calculation, where you calculate the developed length of a sheet metal part using bend calculation tables, which define different angular ranges, assign equations to those ranges, and calculate the developed length of the part. This is another option that is used by individuals experienced in sheet metal design. In closing, unless you are well versed in sheet metal bend allowances, you will find that you use bend table or K-factor over the other 3 options. If you would like to learn more about these different bend allowances, keep in mind that SolidWorks has a great help feature, and there's a lot of information regarding bend allowances. And this will conclude our lesson on bend allowance and bend tables. Edge flange is the next sheet metal feature we will explore. But before we do that, let's edit the sheet metal feature in the Feature Manager tree and apply a gauge table. I'll begin by putting a check mark in front of Use Gauge Table. I'll then select the drop-down list and choose Sample Table, Aluminum. Now once this loads, I'll pick a gauge of 18. That table inserted values for sheet metal thickness of 1.2, an inside bend radius of 1.5, and a bend allowance with a K-factor of 0.5. If you recall in an earlier lesson called Bend Allowance and Bend Tables, we applied a bend table to control the bend allowance. Now what we're doing with gauge table, this single gauge table controls the sheet metal thickness, bend radius, and bend allowance all within one table. So that may save you some time. And we're going to go with these options, so I'm going to click the green check mark. Now let's start an edge flange. I'm going to select the edge flange icon. The property manager opens and it prompts me for an edge. I'm going to go out to the screen, select an edge, stretch out the flange, and pick an approximate point for the height. Going back to the property manager, you see we are using the default radius of 1.5. This default inside radius is taken from the sheet metal feature. Now, if you don't want to use the default radius, you can simply uncheck this box and insert a new value. The next item in the property manager is angle. We have the capability to change the angle of the flange. So watch the screen as I change these values. Notice the angle of the flange changes. I'm going to set it back to 90. The next item in the property manager is the length of the flange. We have three options: blind, up to vertex, and up to edge and merge. I'm going to begin with up to vertex. I'll go out to the screen, select a vertex point, and the flange extends to that point. The next option is up to edge and merge. This is for multi-body sheet metal parts. I'm going to open up another graphic to better explain this. For the up to edge and merge option, the edges must belong to different sheet metal bodies. They must be parallel to each other and have the same thickness. And this option is only available if you select a single edge. So I'm going to close out of this, and we're going to go with the first option of blind. And I am going to set the length of 10 millimeters. Now right below this, you do have control over how that 10 millimeters is applied. Do you want to apply it as outer virtual sharp? And again, watch the screen as I click through these. Or do you want to apply to inner virtual sharp or tangent bend? So you can try these out. You can zoom up, click through these, and see how each one of these options affects the sheet metal part. I am going to go with outer virtual sharp. Right below this, we have the capability to control the flange position. And I'm going to zoom up on this just so it's a bit easier to see. The first one is material inside. The next one is material outside. The third one is bend outside. The next one is bend from virtual sharp. And the last one, which you won't see any difference in the screen, is tangent to bend. I'm going to go with material inside. I'm going to zoom out a little bit. And we also have the capability to apply an offset to this flange. So I'm going to put a check mark inside of this box here. And notice it applies an offset at a distance of 10 millimeters. I can key in a different value or simply use the arrows. And now it's at 20 and you see the preview update. I don't want an offset, so I am going to uncheck this box. Right below this, we have custom bend allowance, which is controlled by the gauge table that we inserted at the beginning of the lesson. And we have custom relief type. And this is a relief cut that is put in the part to make this bend possible. I'll go ahead and close out of the edge flange command so you can see the relief cut here. Now you may also notice that this corner here did not trim back on this adjacent flange. Well, there is a way to fix that. We can go back into edge flange 1, scroll down, and we have an option for trim side bends. So I'm going to go ahead and check it and close out of the edge flange property manager. And notice how it trimmed that adjacent flange. And it did it on both sides, both here and here. Now let's spin the part around and apply a second edge flange. I'll select the edge flange icon, go out and select an edge of the part, stretch it out, pick an approximate height. I'm going to go back to the window, select inside of the window so I can select a second edge and a third edge. You'll see that it automatically miters the flanges and it provides a gap distance between the flanges, and that gap distance is controlled here. And again, we can increase it or decrease it. Now let's talk about these different color arrows. The magenta arrows control the direction of each flange individually. However, the gray arrow controls the length of all flanges within this Edge Flange 2 command. So we've taken a look at this. Let's cancel out of this Edge Flange and try something different. I'm going to go back into the Edge Flange command, select a single edge, stretch it out, and key in a distance of 20 millimeters. I'm going to go back to the top of the Property Manager, and notice I have a large button here for Edit Flange Profile. I'm going to go ahead and select it. A dialog box appears stating that this sketch that you see right here is valid. It also allows you to change the shape or the profile of this sketch. I can grab this line here by holding down the left mouse button and dragging it to a new location. I can apply relations, smart dimensions, just like you would do with any sketch. I can change the shape. And if that's the profile I'm looking for, I can either finish, which would take me out of the Edge Flange command, or I can select back, which will take me back to the Property Manager for Edge Flange. So I'm going to select back, just in case I wanted to make any other changes here. We're going to try one more thing. I'm going to cancel out of this Edge Flange 2, and we're going to go back into the Edge Flange command once again. Select the Edge Flange, stretch it out, and this time we're going to make it identical to the flange on the opposite side. So we're going to set the length to 10 millimeters and trim the side bends. And this concludes our lesson on Edge Flange. In this lesson, we are going to take a look at putting a cut in a sheet metal part. If we go to the Command Manager and look at the sheet metal ribbon, you'll notice we have an extrude cut feature. This is the same extrude cut found in the Features ribbon. So let's return to the sheet metal ribbon and select Extrude Cut. The very first thing I am prompted for is to select a face to create the sketch on. So I'll select this face, view normal to it, and then I'll begin by creating a center line from corner to opposite corner. Next, I am going to add a slotted feature using the center point straight slot and snapping to the midpoint of the center line. I'll then add a couple smart dimensions, a radius of 2, and a center to center distance of 8. I am done with my sketch, so I'm going to close out of the sketch, and the Property Manager appears for Cut Extrude. Now this is identical to the Cut Extrude found in the Features ribbon, with the addition of 2 new options, Link to Thickness and Normal Cut. For now, I am going to uncheck both of these. Then I'll rotate the model to isometric, so it's a little bit easier to talk about some of these options. I am going to begin by changing direction 1 to Through All. Now this would be the obvious choice if you wanted this slotted feature to pass through both flanges. However, at a later time, if you decide to add a tab or another flange in the middle of the part, you may find that this extrude cut passes through that new feature. So this may not be the option that works for you. So let's go back and set direction 1 to blind and take a look at this first option, Link to Thickness. I'll put a check mark here, and what it's doing is linking this cut to the thickness of the sheet metal part, which that setting is controlled in the sheet metal feature in the Feature Manager tree. The nice thing about linking it to thickness is if you decide to change the material thickness down the road, that extrude cut will always pass through the entire sheet metal thickness. To demonstrate the second new option, Normal Cut, I am going to close out of this Cut Extrude and open up another sheet metal part. The part I am going to open is called Edge Flange with Angled Flange, and you can find this in your Working Files folder. Now notice this sheet metal part's almost identical. The only change I made to it is I placed this flange at a 120-degree angle. This will allow me to demonstrate the normal to cut option. So let's go into the cut extrude feature. And instead of blind, we are going to have that extrude cut go through both flanges and close out of the command. Now notice when we zoom up on this slotted feature that this cut is normal to the sheet metal thickness. However, when we zoom up on this slotted feature, it is not normal to the sheet metal thickness. In fact, it's passing through it at an angle. Typically, when we manufacture cuts in sheet metal parts, we place the cuts in the sheet metal parts when the part is in the flattened state. So how do we make that happen here? Well, it's actually pretty easy. We simply go back to the cut extrude feature, edit the feature, and put a check mark in front of normal cut. We close out of the cut extrude command, and now taking a look at that same slotted feature, you will see the cut is normal to the sheet metal thickness. And this wraps up our lesson on cuts in sheet metal parts. Now we are going to take a look at taking the slotted feature we created in the previous lesson using the cut extrude command and duplicating that feature for a total of 15 times. In order to do that, we must go to the Features ribbon and select Linear Pattern. I am going to begin by selecting the Features to Pattern. Now there's a couple ways I can do this. I can select the features right from the model, or I can go to the Feature Manager tree and select the feature from the tree. Typically, you will find it's easier to select from the tree. Going back to the top of the Property Manager, I'm going to select Pattern Direction, and then go out to the model and select this edge here. Now notice the preview. If the direction is incorrect, you do have an arrow to reverse the direction, or you have a button for reverse direction. I am going to set my spacing at 6 millimeters and my number of instances at 8. And again, I want a total of 15. In order to get the remaining 7 instances of the slot, I could close out of this command and use the mirror command and mirror about the right plane. However, seems like it'd make a little more sense if we simply use direction 2. Choosing the pattern direction, I'm going to go back out to the model, select the same edge. Notice the direction is going in the wrong direction, so I need to reverse it. I'm going to set my spacing to 6 and my instances to 8. Now notice I do have an option for pattern seed only. I am going to check this because I want to make sure I don't replicate the pattern from direction 1. Scrolling down the Property Manager, it looks like I have everything else taken care of. So I'm going to close out of the linear pattern. And we now have 15 slotted features. Now we want to get these slotted features on the opposite flange. So we're going to use the mirror command. And in the Property Manager, it's asking me for a face or plane to mirror about. So looking at my Feature Manager tree, it looks like my front plane is in the correct position. So I'm going to go ahead and select it. Next, Features to Mirror. Linear Pattern 1 is correct. So I'm going to go ahead and close out of the mirror command. And we just created 30 slotted features with a couple mouse clicks. In this lesson, we are going to take a look at a feature called Closed Corner. We're going to use this feature to close the 4 corners of this sheet metal part. I am going to begin by zooming in on this first corner here, and I'll rotate the model just so you can see we have a pretty good sized gap between these 2 flanges. And we want to minimize that gap with the Closed Corner feature. To access this feature, we need to go to the sheet metal ribbon and select the drop-down corners and then Closed Corner. The Property Manager opens, and it's fairly short in length, only a few settings here. On the top half of the Property Manager, we have 2 windows, Faces to Extend and Faces to Match. Now before I go out to the screen and select Faces to Extend, I do want to talk about this last option here, Auto Propagation. This is checked by default. What this does is when I go out and select the Faces to Extend, the SolidWorks software will automatically propagate this window here with the appropriate face. So going out to the screen, I'm going to select this face to extend, and like I mentioned, this is propagated, and this is the face too. Moving on down the Property Manager, we have 3 different corner types: butt, overlap, and underlap. Let's try out each one of the 3 just to see how they look on the screen. I'm going to begin with butt and then close out of the feature. And there is a butt corner on the screen. I'm going to go back and edit the feature. And let's change it to overlap. Close out of the feature. And there's an overlapping corner. Go back into the feature again. And then underlap. Close out of the feature. And it's just the opposite of overlap. Now, we are not merging these 2 flanges. We're simply minimizing the gap between them, or the space between them. In fact, I can roll this model around, and you're going to see we still have a small gap present between the 2 flanges. If I go back into the feature, that gap, you do have control over that. Right now, it is set to a gap distance of 0.10 millimeters. And notice you can increase it or decrease it. We have another setting here called overlap underlap ratio. This value can be anywhere from 0 to 1. If I have it set to 1, I have a full overlap like you see here. However, if I have it set to 0, there will be no overlap, as you see here. So I'm going to put it back to 1. Even though the 2 flanges in this model are perpendicular to one another, this command can be used on non-perpendicular corners, and it can also be used on flanges with bends other than 90 degrees. Now, before I close out of this lesson, we can also use this command for multiple corners. And I do want to do that, so I'm going to zoom out a little bit, and I am going to select the other 3 corners. I'm going to pick inside of the window faces to extend, zoom up on the second corner, and select this face. Faces to match, select this face, roll the model around, do the same over here. Faces to extend, faces to match. And the 4th corner. Faces to extend, faces to match. Close out of the command, place it back to isometric view, and we have 4 closed corners. And this concludes our lesson on closed corners. Next, we are going to take a look at how to fold over the edge of this flange and this flange. We do that with a feature called hem, which is located in the sheet metal ribbon. So I'll select the sheet metal tab, and there we have the hem. The very first item in the Property Manager is a window asking me to select an edge or multiple edges. So I'm going to go out to the screen and select this one outer edge. Now notice we have a fairly large hem as a preview. We can change that. But before we do that, notice we have a gray arrow in the middle of this hem. This allows you to flip the hem from the outside to the inside. We have the same setting or the same control in the Property Manager with the button reverse direction. Right below this window we have 2 other options: material inside or bend outside. Let's zoom up on this area so we can better see this. Notice the original height of the flange. With the option set to material inside, the hem does not extend beyond the height of this flange. In fact, if I close out of the hem command, this flange will be trimmed to the tangent line of this hem. With the second option, bend outside, the hem is added to the top of the flange. We'll leave it at bend outside. Right below this in the Property Manager, we need to select type and size of hem. The first one is closed, and notice the preview on the screen. With the closed option, we do have control over the length of the hem. And notice the graphic here with a dimension on it. This length is from the outer tangent point to the end of the hem. I can key in a specific number or use the arrows. The next type is open. With this type, we control the length and gap distance. And also notice this gap distance is an inside distance. The third type is teardrop. With teardrop, we have control over the angle and the inside radius. And notice with the teardrop, the hem wraps around and it makes contact with the flange. The last type is rolled. With the rolled type, we also have control over angle and radius. We're going to set our sheet metal part to teardrop with an angle of 200 degrees and a radius of 0.5 millimeters. Right below this in the Property Manager, we can change the bend allowance and relief type from the default settings found in the gauge table. We're going to leave it with those settings. We're not going to make any changes here. Now, as I said earlier, we could have selected multiple edges. So I'm going to go back and select inside of this window and select this outer edge. And this hem will take on the same settings as the first hem based on these settings here. I'm going to select Edit Hem Width. This says the sketch is valid. It also allows me to change the length of the hem. So notice this dark black line here with the 2 black dots on it. I can grab this left dot, drag it over, and shorten the hem. I can also add relations, or I can add smart dimensions. I'm going to grab this one, shorten it. Let's add a couple smart dimensions. We'll set this one to 10, and we'll do the same with this one. 10. Now if I try to do the same to the opposite side, you'll notice, unlike the first hem, on this side where we have the black line with the 2 black dots, we do not have that black line with the 2 black dots. So we cannot shorten this hem. So if we wanted symmetrical hems, we should not have selected multiple edges. I do want the hems to be symmetrical. So what I'm going to do is I'm going to select back to go to the Property Manager and remove this edge too. I'll close out of the hem command. I now have the one hem on the original side. Now to get the hem on the opposite side, I'm going to have to go to my Features ribbon and select the Mirror command, and it's prompting me for a face or plane to mirror about. I am going to attempt to use my primary planes, and it looks like I can use the right plane, and the Features to mirror is hem 1. And now we have 2 symmetrical hems. We are about halfway through the chapter on creating a sheet metal part. Let's pause for a few minutes and have some fun. We want to take the part that you see on the screen, which is called hem and can be found in your Working Files folder, and we want to add a few more flanges to it, an extrude cut, and a hem. This is what we are working towards. Notice we have 2 flanges here. And notice how the profile of this flange has been changed from the normal rectangular flange. We added a couple hole wizard features, along with an extrude cut down the middle of the part, and a couple flanges over here with slotted features. We also have a new flange here with a closed hem. So let's get started. We are going to begin with this flange here. Going to the sheet metal ribbon, I am going to select Edge Flange. It's prompting me for an edge. Select this leading edge. In the preview is a flange extending the entire length of this edge. How do we modify the profile of that flange? Well, go back to the Property Manager and we select Edit Flange Profile. If you recall, this box appears saying the sketch is valid. This also allows us to change the sketch profile. So I'm going to grab this line here, stretch it down to a smaller size, zoom up in this area. I'm going to select this face so we can view normal to the sketch, and we'll zoom up on the new flange. And let's have some fun modifying it. I'm going to add a couple lines, one here, and one extending off in this direction, and another couple lines on this corner. Let's use the trim feature and trim away a few of these lines. A lot of people don't realize within the Edge Flange command that you can modify the profile to this extent. Now let's add a couple smart dimensions. We'll begin with the outside dimensions. We'll set this to 18. And this one here we'll put at 20. Let's set this to distance of 8. This one to 2. And now going to the back corner, let's put this leg at 10. And this one at 3. And there we go. I am going to pull this window back up on the screen. And if you recall, if I click Finish, it's going to take me out of the Edge Flange Property Manager. However, if I want to go back to the Property Manager and make other changes, I need to select back. So that is what I am going to do. Property Manager opens. I want this to be a 90-degree flange. Material inside. Everything looks good. I'm going to close out of this edge flange. And there we go. Now, let's add a couple hole wizards. If you notice in the sheet metal ribbon, we do have a feature called Simple Hole. However, the two features I want in here are a 3.5mm clearance hole and an M3 socket countersunk head cap screw. So if we do take a quick look at the Simple Hole and we select a face for that Simple Hole, notice in the Property Manager, we can only specify a hole diameter. So not the detail I am looking for. So let's close out of this. Where do we find Hole Wizard? Well, that's back in the Features ribbon. So I'm going to click Features and Hole Wizard. The very first one we're going to start with is the M3 countersunk socket head cap screw. So select countersink and symmetric socket counter head cap screw, M3. And after I make those selections, I need to position it. So I'm going to select the Position tab, go out to the screen, and then place it. After I place it, I am going to add a couple smart dimensions. And from the center to this edge, we'll put it to 6. And from this edge to the center, we'll do 6 again. We'll go back into Hole Wizard, and this time use a simple hole. And the standard is asymmetric. It's going to be a drill size, and the size we are looking for is a 3.5mm. I'm going to go out and position this one, place it on this face, and then once again, add a couple smart dimensions. We'll set this one to a distance of 4, and this one to a distance of 6. Looks good. Let's go ahead and close out of the Hole Wizard. And there we have the two features we were looking for. How do we get the same tab to this back corner? Well, the easiest way to do this is going to be with the mirror command. But before we do the mirror command, we are going to add this flange on this corner. And once this flange is completed, then we can mirror both of these flanges within the same mirror command. So let's work on this one next. Going back to the hem part, I'm going to zoom up on this corner, go back to my sheet metal ribbon, select edge flange, select the edge, pull it out. Let's modify the profile. And again, I'm going to move this off the screen so it's a bit easier to view what we have on the screen. I'm going to select this face here, view normal to it, and we're going to apply a couple smart dimensions. Let's make this 24 by 24. Using the S key, or going back to my ribbon, I want to add a couple slotted features. Using the S key, I'm going to click the drop-down list here, and I want to line this up with the center point. I am going to select Center Point Straight Slot. I'll wake up this line, place my first slotted feature, and then I'll create a second one. Now, before we start to add dimensions to these, I want to talk about the slotted feature. In my classroom, I have a lot of projects that do have slotted features in them. And it seems like early on that a lot of students forget we have a slotted feature option. I see students creating circles, tangent lines, and then trimming those unwanted lines away. So don't forget about that slotted feature. It's pretty handy. Something else people are not generally aware of, when we go to add relations, if we put a smart dimension in this radius, we can make this radius equal to this one. However, if I hold down the control key and select the slotted feature, and then select this one, notice one of my relations I can add is equal slots. I am always surprised about the number of people that are not aware of this relation. So I'm going to select equal slot. Close out of this, and now we're ready to add some smart dimensions. Let's make this radius 2. We'll make this line here 12. And it looks like we need to add a relation to center this. So I'm going to select midpoint, these 2 points here, and then select vertical. Now, I am done with my sketch, so I am going to pull this window back up on the screen. I want to go back to the property manager, so I'm going to select the back button. And I want this to be a 90-degree flange with the material to the inside. So everything looks good. I'm going to close out of this, and we have our next flange created. Let's put it back to an isometric view. Now we need to add 2 last location dimensions from the outer edge to the center line. We'll set this to 6 and this one to 12. Now we are ready to mirror those 2 flanges. So I'm going to expand this here. I'll want to try to use my primary planes to mirror about. So let's turn them on just to see where they're at. I'm going to go to my Features ribbon, select the Mirror button, and Mirror Face Plane. It looks like right plane would be the correct plane, so that's good. And the Features to mirror, I'm going to expand my Feature Manager tree, and it begins with Edge Flange 3, so I'm going to hold down the Shift key, and then select Edge Flange 4 because we want it to include the hole wizards along with that last flange that we created. Click OK, and we mirrored the features. And this concludes part 1 of testing your skills. Let's continue with testing your skills. First, I am going to hide the primary planes and then hide the display plane. Next, we need to add a couple additional features. Looking at the finished part, we need this extrude cut and this one last flange with a hem. So let's go back to our part. And let's start with the extrude cut. Now, if you recall from an earlier lesson, we talked about the slight difference between extrude cut found in the features ribbon and the extrude cut found on the sheet metal ribbon. The difference is we can link it to the sheet metal thickness if we select the extrude cut from the sheet metal ribbon. So let's do that. The very first thing it prompts me for is my sketch plane. I'll rotate normal to it, zoom up a little bit, and we are looking for an octagon with a 65mm distance across the flats. So I'm going to go to my octagon command, make sure the number of sides is at 8, go out and select my center point, and then drag it out. I am going to add a relation between the front plane and this bottom line here as parallel. And that will position the octagon in the correct orientation. Now let's add a smart dimension of 65mm across the flats. Looking at the finished model, we had a couple rectangular cuts. Now there's a few ways you can do this. I think one of the easier ways to do it is simply use a center point rectangle. So I'm going to grab the center point, stretch it out, apply a couple smart dimensions. We'll set this one to 75 and this leg to 20. Now before we finish the sketch, we need to trim a few of these lines. There's a number of options for trimming. I am going to select Trim Away Inside. I'll select my two bounding entities and then select the lines to trim. I'll do the same in this direction. Now I'm going to zoom up and use Trim the Closest. And trim this back so we have a couple sharp corners there. And do the same on this side. Looks like the sketch is completed. I'm going to close out of the trim command, close out of the sketch. And before we leave the cut extrude, just make sure we're linked to the thickness. That way, if we decide to change the sheet metal thickness at a later time, the extrude cut will pass through that entire thickness. Okay, a couple last items to add. We're going to go back to the sheet metal ribbon, and we're going to add an edge flange and a hem. So our model appears like this. Now this edge flange will be the correct length because the flange is for the entire edge. And it terminates at these two flanges here. We're going to change a few of these settings in the property manager. We want the flange length to be blind at a distance of 12. And I do want it to be at outer virtual sharp and material outside. Close out of it. And the one last item to finish off testing your skills is to add a hem. So we're going to select this edge here, and we are looking for a closed hem, and we want the hem length to be 4 millimeters. We're also going to have this closed hem bend outside. Closed hem and a length of 4. And there we go. That was testing your skills. In this lesson, we are going to examine a new feature which allows us to add flanges to this existing sheet metal part. Now, if you look at the property manager, so far we've been using a lot of edge flange features. What we want to do with this model is put a bend in this flange here and this one here. Let's take a look at the finished part. Notice the bend. So going back to our part, how do we do that? We're going to do that with a feature called Sketched Bend. So I'm going to select Sketch Bend, Property Manager opens, and I have a message of select a planar surface on which to sketch the bend line. So I do need to sketch a line here telling SolidWorks where I want the bend to take place. So I'm going to select this face here, and it can be the face of either of these flanges. And now I am going to go to my line command, and I'm going to zoom up on this. And I want this bend line to be 12 millimeters from this edge here. So I need to be careful that I do not snap to this midpoint because this is not 12 millimeters away from this edge. I'm going to make sure I select a little bit away from this and then draw that bend line across both flanges. I'll then apply a smart dimension of 12 millimeters. And you can see the midpoint and this sketch line. It's a slight difference between them. So you got to be careful not to snap to that midpoint. Now, since I created the required sketched line, or bend line as they call it, I am going to close out of the sketch, and the property manager appears. The very first window in the property manager is asking me to select a fixed face. This would be the portion of this flange that does not change or bend. So I want to select on this side of the sketched line. So I'm going to select this point here. And notice the black dot. We have 4 choices for bend position: bend at centerline, material inside, material outside, and the entire bend on the outside. I'm going to leave it at bend centerline. You can also adjust this bend to be anywhere from 0 to 360 degrees. And notice we do have the standard options that we see on many of the other property managers of radius and bend allowance. I'm going to leave these settings and click OK. And there we have 2 new flanges using the Sketched Bend feature. Looking at the feature manager tree, you can see we've added several features to the sheet metal part. The first one was base flange. Now if we go to the command manager and select the sheet metal tab, and take a closer look at the base flange button, we will notice it actually says base flange / tab. And that's because this button serves two purposes. First, it will create a base flange like we did at the very beginning of the sheet metal part. It will also create a tab on an existing sheet metal part. The tab feature will add material at the same thickness and direction of a sheet metal face. So let's begin. We are going to add a tab inside of this opening here. The tab is going to be rectangular in shape. So I'm going to zoom up on this area, select the tab feature. A message appears asking me to select a planar face on which to create a sketch. So I'm going to go out to the screen and select the top face. Now before I proceed, I am going to view normal to this face and then zoom up on this area. I am going to start the corner rectangle, apply a couple circles, and then a handful of smart dimensions. This first one will be 25. From the edge of the tab to the center of the first hole will be 5. And from the edge of the tab to the center of the second hole will be 12. I'm going to set the space to 1 millimeter. And the same on this side. Let's change diameter 4. And now let's add a couple relations. I'm going to add a relation from midpoint along with center point and make those three horizontal to one another. I'm also going to add an equal relation for the two circles. And there we go. Our sketch for the tab feature is complete. So we're going to close out of the sketch. Property Manager opens. Now notice, in my opinion, this should be called tab, but instead it's listed as base flange. Could be a little confusing. As we look down the Property Manager for tab, most of these options are grayed out because they are taken from the gauge table that we inputted or applied many lessons ago. Now we can override those, but we're going to go with the default settings. Notice Merge Result is checked by default. That's basically telling you that you are going to merge this tab with the surrounding sheet metal part. And typically, you want to do that. So we're going to close out of the tab Property Manager and place it back to an isometric view. And we have our first tab. Now let's place that same tab over in this area. And the easiest way to do that is by going to the Features ribbon and selecting Mirror. A SolidWorks message has appeared on the screen, and this message is telling us the part was created in an earlier version and must be rebuilt. We do want to rebuild it, so we are going to select Yes. I'm going to select a plane to mirror about. I'll use one of my primary planes, and it looks like the right plane is the correct choice. I am going to mirror tab 1, close out of the feature, and now we have two tabs. In this lesson, we are going to take a look at adding a jog, otherwise known as offset, to the two tabs that we created in the previous lesson. Now to show you what we're working towards, let me go to a finished model. And there's the two offsets or jogs added to the tabs. So I'm going to go back to our model. And then in the sheet metal ribbon, I'll select the jog feature. In this message, I am prompted to select a planar face on which to create a sketch for a bend line. So I'm going to go out to the screen and select the top face. I'll zoom up on this first tab, roll the model, just so it's a bit easier to see. To create a bend line, I'm going to grab the line tool. I am going to draw a line from this corner to this corner. I should mention it's best practice when you create bend lines that the bend line extends across only the piece of sheet metal that you are bending. But it's not a requirement. And since I have these two convenient corners here, I am going to use them and snap to them. Now I don't need any smart dimensions. I am done with my bend line. I'm going to close out of the sketch. And we see the Property Manager for jog. The very first window is prompting me for a fixed face. So I'm going to go out to the screen and select on this side of the bend line. This face will remain stationary. And notice the preview of the jog in the tab. Going back to the property manager, we are using the default radius, and like other property managers, we do have the capability to override that and specify a different radius. We're going to stay with the defaults. Going down to jog offset, I can reverse the direction of the jog. Now the jog is on the bottom side of the part, and now it's back on the top side. As far as length of the jog, I do have 4 options: blind, up to vertex, up to surface, and offset from surface. I'm going to select blind, and we are going to use a value of 12. Right below this, we have dimension position. And these buttons, the graphics on them are excellent. They show you exactly how that 12 millimeter distance will be applied. The first one is outside offset. The second one is inside offset. And the last one, overall dimension. We are going to use inside offset. Right below this, we have a checkbox for fix projected length. And this is checked by default. What happens here is, when this jog is placed in the tab, material is added to the tab, so this jog tab is the same length as the original flat tab. So if I go back and uncheck that, watch the preview on the screen, and you will see the tab is much shorter. So I'm going to put a check mark back in this box. Moving down the property manager, we have jog position. The first one is, do you want the jog to take place on the bend center line? The next one, material inside. The third one is material outside. And the last one, the bend completely on the outside. We'll go with material inside. This next setting is always fun to play around with. It defaults to 90, but you can change the jog angle. And watch the preview on the screen. And I'll set it back to 90. And the last item in the property manager is bend allowance. And we're going to leave it with the default. I'm going to close out of the jog feature. And as you can see, we applied a jog feature to the first tab. Now, unfortunately, the SolidWorks software does not allow us to mirror a jog feature. So we're going to have to do that jog feature a second time for the second tab. So I'm going to go and select the jog feature. Select a plane on which to create a bend line. Add my bend line in the same position as the other tab. Close out of the sketch. Select a fixed face. And verify the settings are the same. Blind, 12, inside offset, material inside, and a jog angle of 90. Looks like we're good. I'm going to close out a jog, and there we go. We added 2 jogs to those 2 existing tabs. In this lesson, we are going to take a look at a feature called break corners. The break corner feature allows you to place a fillet or a chamfer on a corner or corners of a sheet metal part. So let's go to the drop-down corners and select break corner, corner trim. As soon as the property manager opens, you will see it's fairly short in length, very simple to work through. The very first window in the property manager is prompting me for an edge or face. So this command turns on a filter which only allows you to select an edge or face. I am going to zoom up on this flange here and select this edge. Now I can continue working around the part selecting edges, or I can simply clear the window and select a face. Returning to the property manager, notice the break type is chamfer or fillet. Now you may be wondering, what is the difference between this command and the chamfer fillet command found on the features ribbon? There is really no difference other than this is placed on the sheet metal ribbon for convenience purposes. So I am going to zoom out. I'm going to select a few more faces. And now let's change the chamfer size to 2 millimeters. And notice all outside corners on those 4 flanges have been selected. I will close out of the break corner property manager, and the model is updated. And this concludes our lesson on break corner. When we began creating the part you see on the screen, the very first feature we created was a base flange. Now, if you recall, when we created that base flange feature, SolidWorks added 2 additional features to the feature manager tree. One being the sheet metal feature, and the second one, flat pattern feature. In this lesson, we are going to take a closer look at the flat pattern feature. So I am going to expand it and edit the flat pattern. The Property Manager opens for Flat Pattern, and the very first thing in the Property Manager is a window for Fixed Face. Fixed Face is the face that remains stationary while rest of the part or rest of the faces bend and unbend around the fixed face. Now, to change the fixed face, it is simply a matter of clearing this window and then going out to the screen and selecting a different face. The next item in the Property Manager is Merge Faces. By default, Merge Faces is selected, so if we leave it checked and close out of Flat Pattern, and then select the Flatten button, notice when I select the face, the entire sheet metal part is selected and is being treated as a single face. However, if I go back and edit the Flat Pattern and uncheck Merge Faces, you will see as I select different faces on the sheet metal part, they're treated as separate faces. Let's go back into the feature, edit the feature, and recheck Merge Faces. Simplify Bends is the next option in the Property Manager, and this part does not lend itself well to demonstrating Simplify Bends. So let me open up the Help screen. In the Help screen, you will see 2 graphics representing the same flattened part. When Simplify Bends is selected, it's taken that original radial edge and straighten it to make the part easier to manufacture. If the Simplify Bends checkbox is unchecked, notice it's placed back to the original radial edge. Let's go back to our part. And now we're going to take a look at corner options. Under corner options, we have corner treatment. By default, this is also checked. When corner treatment is checked and you unfold the part, or flatten the part is the correct term, you will notice corner treatment is applied and it is showing a corner that can be manufactured. However, if we go back into Flat Pattern and uncheck corner treatment, close out of it, you will see no corner treatment is applied, making it difficult, if not impossible, to manufacture this part. Let's go back into the feature one more time. The next item is grain direction. SolidWorks provides you the capability to specify a grain direction for the sheet metal part. And it's as simple as selecting inside of this window and selecting an edge. By selecting that single edge, I specified grain direction. The last item is faces to exclude. I am going to open up another model, which is called Flat Pattern. And notice in this model, I put a stiffener in the back corner. Now when I go to flatten this multi-body part, I will receive an error message stating the part cannot be unbent. So how do we remedy this problem? Well, we simply go back into Flat Pattern, edit the feature, select inside of the window for faces to exclude, and select the faces that make up this stiffener. So I'll select this face, roll the model, select this face, spin the model to the bottom side, and with my right mouse button, select Other, select the appropriate face, and then close out of the Flat Pattern feature. Since I excluded those faces, you will see SolidWorks is able to flatten the sheet metal part. Let's go ahead and unflatten the part, fit it to the screen, and this concludes our lesson on Flat Pattern. We are going to continue discussing Flat Pattern in this lesson. In fact, we're going to take a look at how to add corner relief and breaking of a sharp corner in the flattened state. Before I select the flatten feature, I want to take a look at the drop down for corners. And I want you to notice we have 4 options: closed corner, welded corner, break corner corner trim, and corner relief. If I flatten the part and I go back to the drop down corners, I have a new option called corner dash trim. I am going to go ahead and select it. The Property Manager opens, and notice we have 2 subheadings: relief options and break corner options. We are going to start with relief options. Now, in this first window, I am prompted for corner edges. I can go out to the screen and select individual corner edges, or I can simply click Collect All Corners. So by selecting Collect All Corners, notice 4 corners are selected. Right below this, I have the option of 3 relief types: circular, notice the preview on the screen; square, notice the preview again; and the last one, bend waste, and notice this preview. I am going to return to a circular relief type, and right below this, I have an option for centered on bend lines. Right now, the circular relief is positioned at this intersection, but if I select centered on bend lines, the circular relief is positioned based on the intersection of these 2 bend lines. Right below this, I can set the size of the radius for the circular relief, or I can make it a ratio to the thickness. I'm going to go back and change it to a square relief type, and notice I have the same settings. With the relief type being set to square, I can add fillets to the corner of the square relief type. Notice I can specify the size and watch the screen as I increase the size. Notice how the corners are filleted. We are going to leave it with these current settings, and let's go back to an isometric view so we can see the entire sheet metal part, and now move down to the break corner options of the Property Manager. In the break corner options, I have a window prompting me for corner edges or faces. And again, I can go out to the screen and select edges or faces, or simply select Collect All Corners. Notice the checkbox for internal corners only is selected, so it's only breaking inside corners as you see here. However, if I uncheck it and collect corners once again, both inside and outside corners are now selected. I am going to recheck the internal corners only. That break type can be a chamfer or a fillet, and we can control the size of either of those. I am going to close out of the corner trim feature, and notice the preview on the screen is updated. Now, this corner trim that we see in the flat pattern state only applies to the flattened state. You will not see this corner trim when we unflatten the part. Keep your eye on this square relief. I will unflatten the part, and notice it does not apply to the part in the unflattened state. And this concludes our lesson on corner trim in flattened state. In earlier lessons, you may have noticed as we flatten and unflatten the sheet metal part that we have 2 commands above the flatten feature that look to do the same thing: unfold and fold. And you may have been wondering, how are these different from the flatten feature? The flatten feature flattens the entire sheet metal part. For the unfold fold feature, you can specify exactly what is unfolded and what is folded. So let's give it a try. We are going to zoom up on this one flange here, and let's assume we want to place a rectangular cut into this flange. In order to place that rectangular cut in the flange, we need to do that in the unfolded state. So we need to unbend this flange. So I'm going to select the Unfold button. A very simple Property Manager opens. The very first window is prompting me for a fixed face. Now this is the face that remains stationary when this flange is unfolded. So I'm going to select this face here. The next window in the Property Manager is prompting me to select the bends to unfold. So I'm going to select this bend. We also have the option to collect all bends, which if we did this, would obviously select all the bends and unfold the entire sheet metal part. That's not what we want to do. We simply want to unbend or unfold this one flange. So we have everything selected correctly. I am going to click the green check mark and notice the flange is unfolded. Next, I am going to go into Extrude Cut, select this face to create my sketch on, select Corner Rectangle, and place a rectangular sketch right about in this location here. Let's apply a couple smart dimensions. 2 millimeters from the edge, along with 2 millimeters for the width of the slot. We'll apply height of this rectangular slotted feature at 10. And now let's center it in the bend. I am going to create a construction line from midpoint over to this midpoint. Then I'll go back and add a relation to this construction line of horizontal. And now it's centered. Since my sketch is complete, I'm going to close out of it. In the Property Manager for Cut Extrude, I am going to link it to the thickness of the sheet metal. Everything else looks good. Close out of the command. And there we have our rectangular slotted feature. Zooming out a bit, we are now ready to take this flange and place it back in the folded state. In order to do that, we need to use the Fold feature. So selecting Fold, the Property Manager opens. It appears the proper fixed face is already selected. The bends to fold would be this one here. Close out of the command, and there we have it. Using the two features, Unfold and Fold, we added a rectangular slotted feature in the one flange. And this concludes our lesson over those two features. Now we are going to take a look at a feature that was added in SolidWorks 2014. This feature is Sheet Metal Gusset. Sheet Metal Gusset allows you to add a gusset or rib across a sheet metal bend. So let's assume we want to add a gusset between these two sheet metal faces. We would simply go to the Sheet Metal Gusset button. The Property Manager opens. The very first window is prompting us for a bend face or two planar faces that are adjacent to a bend. Now, what is the bend face? Well, if we want the gusset to be between these two faces here, the bend face would be this area or this face that I have my mouse above. You can select bend face, or you can select two planar faces that are adjacent to the bend. I'm going to select the two planar faces. 1, 2. And now we see the preview of a sheet metal gusset. SolidWorks automatically calculates a linear entity in which to position or align the gusset. And you can see that on the screen by this purple line. SolidWorks also selects a point in which to dimension and locate the gusset from. And again, SolidWorks selected this point. You can choose other points such as sketch points or endpoints or midpoints just by simply clearing this box here and selecting a different point. So if I select the midpoint of this line here, notice there's the midpoint, there's the gusset. It appears it's not positioned on that midpoint. That's because offset is checked and it's set to a distance of 10. If I uncheck offset, now you see the gusset is positioned at the midpoint. I am going to place a check back in offset, clear the selection for the dimension point, and reselect the endpoint of this line. And now the gusset is back to the original location. Moving down the Property Manager, we have Profile. If you want a symmetrical shaped gusset, you want to leave the indent depth as your choice. This is a symmetrical gusset. Dimension D, if we look at the graphic here, we can change that. Currently it's at 5 millimeters. If I change it to 4, watch the preview update, and the gusset is now a bit smaller. If you want an asymmetrical gusset, you do have that capability by checking the Profile Dimensions radio button. And this gives you control over the various dimensions that you see in this graphic here, making the gusset asymmetrical. I'm going to put it back to indent depth. I'll set the depth to 5. Moving down the Property Manager, we can select between a rounded gusset, which we currently see on the screen, or a flat gusset. And notice when I select flat gusset, I will get a new option in the Property Manager. So I'm going to select flat gusset, and notice I can control the edge fillet. That will be a fillet on the very edge of this gusset. Let me go ahead and close out of the sheet metal gusset feature, and you will see that fillet of 1 millimeter. Let's go back and edit the gusset. We will return it to a rounded gusset. And the last part of the Property Manager is dimensions pertaining to the gusset size itself. We have an indent width and an indent thickness. And by changing these values, you can see the preview update on the screen. We also have the capability to apply draft, inner corner fillets, and outer corner fillets. Let's try inner corner fillet. I'm going to change this to 0.5 millimeter and outer corner fillet 0.5. Go ahead and close out of the sheet metal gusset feature, and there we have a 0.5 fillet on the outside and on the inside. Go back into the feature. And the very last item is the preview, partial preview or full preview for gusset. We'll go ahead and close out, place it back to an isometric view, and there we have a sheet metal gusset. Now, just like any other features in your feature manager tree, you can always go back and edit the gusset like we've done many times already and make changes to these settings. Let's bump this offset to 20. Close out, and this concludes our lesson on gussets. In SolidWorks 2015, a new enhancement has been added for sheet metal gussets. Before SolidWorks 2015, if you were to flatten a pattern, for example, if we flatten this sheet metal part, which has 2 sheet metal gussets, those gussets would not appear in the sheet metal pattern. Notice we do not see the gussets. Now in 2015, the new enhancement gives us that option of showing the gussets in the flat pattern. The way we turn this option on is we go to the Options dialog box, we switch over to the Document Properties tab, go down to Sheet Metal, and at the bottom here, you see we have 2 choices. Show sheet metal gusset profiles when flattened, and show sheet metal gusset centers when flattened. You can check one or check both. I am going to check both and then select OK. Now when I flatten this part, you'll see a profile for each gusset and a center point for each gusset. You can override those settings that we just set in the Options dialog box by going to the Feature Manager design tree. I am going to edit Sheet Metal Gusset 1, which is this sheet metal gusset. I'll edit the feature. I'll scroll down to the bottom of the Property Manager, and notice under Flat Pattern Visibility, the Show Profile and Show Center are grayed out. However, they are checked. They are active and turned on. And that's because of the settings we just set in the Options dialog box. You can override those settings by putting a check mark in the Override Document Settings. I am going to turn off Show Center. I'll close out of the Sheet Metal Gusset command. And notice in the flat pattern, the center point for Sheet Metal Gusset 1 is not showing. In this lesson, we are going to take a look at another type of flange. We've already examined edge flange in an earlier lesson. Now we're going to take a look at creating a miter flange. But before we can do that, we must first create a base flange. So I'll select the base flange feature. A message appears asking me to select a plane on which to create a sketch. I'll select the top plane. I am going to create a center point rectangle. And this rectangle will have a size of 200 by 300. My sketch is complete. It's fully defined. I am going to close out of the sketch. The Property Manager now opens for base flange. You may notice a slight difference in this base flange Property Manager as compared to the property manager for the base flange in a part that we created in an earlier lesson. In this base flange property manager, we do not have the option to set the extrude distance. And the reason for that is this sketch is a closed profile, where the earlier lesson, if you recall, was an open profile. It was a U shape. So how do we control the thickness of this part? That's controlled right here, sheet metal parameters. The thickness is currently at 1, so we are going to go with that thickness. We have bend allowance and auto relief, just like we did before. So we're going to keep these default settings for bend allowance and auto relief with a thickness of 1 millimeter and close out of base flange. Now, since we have a base flange created, we are ready to start a miter flange. So I'll select the miter flange feature. I receive a message. Now this is the point in which a lot of people get hung up in this command. If you want the miter flange to extend down this edge here, you need to create your sketch profile on a plane perpendicular to this edge. And that's what this message is telling us. Select a plane, a planar face, or an edge on which to sketch the feature cross-section. So once again, if we want the miter flange to extend down this edge, we need to select a plane perpendicular to it. So if I zoom up on this corner here, this face, this plane, is perpendicular to this edge. By selecting this face, I am taken into the sketch mode. I'll go to my line tool and sketch a profile. Now my profile sketched. Let's add a couple smart dimensions. Let's set this leg to 30. This leg to 20. We'll do 15 here. And 15 for the last leg. Once again, my sketch is completed. It's fully defined. I am going to close out of the sketch. But before I do that, notice I did not sketch any fillets or radiuses in these sharp corners. And the reason for that is we're in the sheet metal environment. And since we're in the sheet metal environment, the radiuses will be added automatically. So again, let's close out of the sketch and you will see the radiuses added. Now how do we change those radiuses? Well, that's in the property manager for the miter flange. Notice we have use default radius. And just like other commands that we've talked about, if you do not want to use a default radius, you simply uncheck this box and type in a different value. We're going to stay with the default radius. As I zoom out and go back to an isometric view, notice by creating that sketch on a plane perpendicular to this edge, the miter flange extends the full length of this edge. Before I talk about flange position and these couple other options that we see here, let's first talk about start, end, offset. Notice this miter flange starts here, ends here. We have the capability to change the start offset. And watch the preview on the screen. There's an 80 millimeter offset from the start point. And we can do the same for the end offset. Once again, an 80 millimeter offset. So we basically end up with a flange which is centered in this edge. Now since we understand how start and offset works, let's set the values back to 0. We'll return to the top of the property manager, and now we're ready to talk about adding additional edges. We can add additional edges to place this miter flange as long as the edges are in contact with the original edge. So I'm going to select this edge here. Notice the preview update. Now this edge is in contact with this one. I can select this edge and do the same for the last edge. Now this miter flange wraps all the way around the base flange. If I zoom into this corner here, we can now talk about flange position. We've seen these options before in other commands. The first one is material inside. That means that this miter flange will be placed inside of the base flange. So the overall size of the base flange does not change. However, if we go with material outside or bend outside, the overall size of the base flange will change. Let's set it back to material inside. Then we have trim side bends, just like we do with edge flange. And then our last option is gap distance. Now if we zoom in, you can see we have a small space here. That small space is 0.5 millimeters. Let's change it to 0.25. And you see the gap decrease. If I go back to an isometric view, we have a miter flange that extends all the way around the perimeter of the base flange. Now, what's the benefit of the miter flange over the edge flange? The miter flange allows you to incorporate bends into your sketch profile, where if you recall, the edge flange simply allows you to create a flange perpendicular to the edge you selected. So the miter flange has some really nice capabilities. And this concludes our lesson on miter flange. In this lesson, we are going to examine another sheet metal flange. We've already covered in earlier lessons base flange, edge flange, and miter flange. Now we're going to take a look at swept flange. However, if you look through the sheet metal ribbon, you will not find a swept flange feature. So how do we get to it? Well, one method is to go to the Insert pull-down menu, Sheet Metal, Swept Flange. But if you are going to be using this feature on a regular basis, it would be more efficient to place this feature on the sheet metal ribbon. So let's do that. I am going to select the drop-down options and then Customize. Once the dialog box opens, I'll select the Commands tab and then look for sheet metal. There's sheet metal. I'll select it and then locate the swept flange feature, which here it is. I am going to hold down the left mouse button and drag it to the sheet metal ribbon. It's as simple as that. The best way to describe the swept flange feature is if you were to take the edge flange capabilities and the miter flange capabilities and merge them into one command, and that is swept flange. This swept flange feature is also very similar to the sweep found on the features ribbon, the swept boss base and the swept cut. Now both of these sweep features require two sketches before you activate the feature, a profile sketch and a path sketch. This is true for the sheet metal swept flange feature. Let's begin with our profile sketch first. I will go to the sketch ribbon, select sketch, and we're going to create our profile sketch on the front plane. We're going to have some fun with this. We're going to create a flange. It has a couple bends to it and an arc. We'll place a couple smart dimensions on it. Let's make this 30. We'll also make this 30 by 30. And we'll make this leg here 25. The radius 20. Before we leave the profile sketch, it's important to mention that the profile sketch must be an open profile. If you were to close this profile, the swept flange feature will fail. So there's our profile for the flange. I'm going to close out of the sketch. And now we're going to create a sketch on a plane perpendicular to the front plane. So I'm going to create my path on the top plane. I'll go to the Feature Manager tree, right mouse click on top plane, and begin a new sketch. Let's view normal to the top plane. Zoom out a little bit, and then begin my path. And we'll put an arc in this path, just so you can see how this swept flange feature works, and just how versatile it is. Let me add a couple smart dimensions to it. We'll make this 200 with a radius of 100, and this length here we'll put at 125. And to get it fully defined, let's place an angle of 30 degrees. Now our path is fully defined. Let's close out of the path sketch. We'll go back to an isometric view, and now you see our profile which has to be open, and then we have our path. This path can be open or closed, but the profile must be open. Now we're ready to go back to the sheet metal ribbon and select the swept flange feature. In the Property Manager, we have Profile and Path windows. It appears that I do have the wrong sketch for the profile, so I'm going to clear the selections, expand the tree, and select Sketch 1 as my profile. And this is Sketch 1. I'll then select the path, which is Sketch 2, and notice the preview of the swept flange. Now there is no need to place any radiuses on that profile sketch because we're in the sheet metal environment, and that's taken care of by the sheet metal feature. Notice we have all of our parameters: thickness, radius, bend allowance, auto relief, just like we did with the other flange commands. We're going to keep the default settings and close out of the swept flange feature. And just by doing a couple sketches, you can see we created a pretty complex sheet metal flange. Now it's real easy to have fun with this command, get carried away, and design a part that's not manufacturable. So always make sure you flatten the part